Welcome back, Swifters. This is Prof G, and I'm wondering, are you frustrated with your app that it's tough to Sherlock through and find the exact Pokemon that you're looking for? Well, this would be much easier if we added a search bar to our Catch-em-all app, and that's just what we're going to do in this lesson. Let the hacking commence! So the first thing we're going to do is get a search bar to appear at the top of our list. And while it'll take more code to make this functional, getting it to appear is super easy. We simply add a .searchable modifier to our list. I'll code fold our list just so that we can see its modifiers more clearly, and at the end of the toolbar modifiers closing curly, I'll just add .searchable. Now select the option with just the text attribute. Notice that this is a binding string, and this is going to contain the string that the user types into the search field. So press return to accept this, and now we're going to have to create a variable to hold this binding string value. So up top, under my @state object, I'm just going to enter @state private var, we'll call this search text, equals empty string. Then we'll return to our searchable modifier that we just entered, and we'll pass in $search text as our binding string. And search my Snorlax, Swifter, will you look at that? We've now got a search bar up top. Now, unfortunately, it does not work yet, but let's make this happen. And actually, before we code the search, let's break out the code that's in our task modifier below our lazy V stack. You see, this code handles JSON paging, and since it's associated with loading more creatures data, why don't we break it out and code it as a callable method of our creatures class. This compartmentalizing of a class's data with all the data access methods associated with that class is considered to be a better programming practice. The reason why this makes sense is if there are ever any changes to the API that we're accessing, well, we can do them in just one place in our class file instead of hunting through our code. So I'm going to first highlight everything that's inside of the task block's curlies and cut it out, and then head over to the creatures plural class. And why don't we put this just before the load all function? We'll add another function, func load next if needed. We'll start off with open and close parens and open and close curlies, and in between the curlies, let's paste in what we just cut out. And also notice, since we're now inside of the creatures class, we no longer need to refer to creatures dot before referring to creatures array. So I'm going to get rid of that. And I'll also get rid of creatures dot in front of the URL string here. And let's see, with this value that I just highlighted, we should be comparing the current creature that has just appeared in our onAppear with the last creature in the creatures array. Now we can't do this unless we actually pass in that creature that just appeared. So let's add a parameter to our function between the parens that says creature colon, and this is of type C creature. Oh, and I also need to get rid of creatures dot in front of get data, again, because I am in the creatures class. And another change I'm going to make to this code is instead of comparing the dot name properties in this if line, I'm going to change them to dot ID. Remember, dot ID is better because it's guaranteed to be unique. And it's also important to remember, although Xcode would remind us if I forgot this, since we're writing a function that calls an async function with an await keyword, we want to add the async keyword just before the opening curly of the function. Click Fix and let Xcode make the change. And this little bit of refactoring is done, so now let's make sure that we call it properly in our creatures list view. We'll head over there, and back in our task modifier, we'll enter creatures dot load next if needed, and note that this is an async function. We know what that means. I'll first pass in lowercase creature, and remember, if you forget, Xcode's gonna warn you. It's gonna issue an error. Click on this. Oh yeah, the async function goes hand in hand with await, so why don't we click on fix to fix that? Await goes out front, and we're looking good. So we can resume our live preview, and if we scroll, we can see that the next page of JSON is loaded when it's needed. You can click on load all. This works too, although we didn't impact any of the code in load all, but it's nice to know that everything is working. This all works great. Now we're ready to actually get our search bar to work. And the way we're going to make this happen is to create a computed property that contains an array of creatures that contain any phrase that the user enters into the search bar. Then we'll use that filtered results computed property, which we'll call search results, in our list in place of the full list of creatures.creatures array. So just above the closing curly in my creatures list view struct, I'm going to create a new variable. This is again going to be a computed property. So I'll say var, I'm going to call this search results, lower camel case. Then I'll say colon, bracket, C creature, bracket, because I want this to compute a result that is an array of creature structs. And then I'll open and close curly, and this is where we put in the calculations that will compute the result that we return. So in this computed property, again, it doesn't store data. It's going to calculate calculate what should appear in this value in between the curlies, we're going to do this based on what's inside of the search text variable, which is what the user entered into the search bar. So we're going to start by saying if search text dot is empty. And if this is the case, meaning the user hasn't entered anything into the search text, then we want to return all the creatures that we've downloaded. So between curlies, we'll say return creatures dot creatures array. No change. We didn't search on anything. But else, open and close curlies, if we have something in search text, then we'll return the results of filtering out just the array elements that contain the search text value. And we do this with return creatures.creaturesArray.filter. This is that higher order function that will filter out just the results that match a criteria. So I'm going to press return to accept this, and I'm going to use the shorthand in here. So I'm going to delete any parentheses that I have in here and replace them with the open and close curlies of a closure. And in the closure, I'm going to pass in $0. That represents each creature that we're iterating through in this creatures.creaturesArray, followed by .name.capitalize. We want to have that in here since we've got capitalized results. And we'll say .contains, press return to accept this, and we're going to pass in search text. And now in either case, we are going to have an array called search results, which will contain either all of the creatures array if there's nothing entered in search text, or it's going to contain just those elements of creature array that match the search result that the user entered in the search text. So now what do? Well, we want to make one more change, and that's in our list. Instead of passing in the full creatures.creaturesArray, if we option click on the creatures array, remember, this is an array of creature struct, we're going to instead pass in search result, which remember, if we option click on search results to check its type, it's also an array of creature types. So search results is the filtered set of the returned Pokemon. It's a drop-in replacement. So now let's try this out. I'm going to load all my Pokemon. I'm going to search for everybody's favorite, Snorlax. And ooh, I didn't know there was a snow runt. Why don't we look at that guy? And then we'll go back and we'll look at Snorlax, and there he is, looking happy and sleepy as ever. Nice work, Swifter. Search field complete. Ooh, and before we finish the app, I remember now, in an earlier lesson, I promised to show how to get back our index number that had appeared in front of each Pokemon in the list. And this is a little bit harder because we're no longer using an index to iterate through all of our Pokemon, but it's not too hard. What I'm going to do is I'm going to create a function that returns the index of the Pokemon being displayed on a particular line in the label inside of this list. So in the label, let me first put creature.name.capitalized inside of a string, and inside that string, I'll enclose it in a string interp. Then I'm going to put another string interp at the start of this string and follow that with a period space. And then inside this string interp, I want to call a function to return the index of the creature that we pass into it. But before we do that, we have to write the return index function. So I'm going to do that at the bottom of the struct, just before the closing curly of the struct. Why don't we say func return index, and in parentheses, I'm going to use two labels. I'm going to say of creature. So of is the argument label, creature is what I'm using inside the function, colon, capital C creature, and then I'm going to return an int. And between the curlies, I'll say guard let index equals creatures dot creature array dot, and I'm going to use the method called firstIndexWhere. So code completion says this returns the first index where an element in a collection, meaning our array, satisfies the given predicate, which is what we're going to put inside of the closure. It'll essentially tell us the first index where a value's found. And what we're going to search for is a particular creature name. Now this takes a closure, so in between curlies, I'm going to put in the value that I want to filter. And the where condition is going to be $0. Remember, that's each value in the creatures array, .name equals creature.name, the name of the creature that I'm passing in. Else, and in between parentheses, I'll say return 0. So that's just if nothing returns from the first index where method, but it's always going to return something. Otherwise, I'm going to return index +1. And remember, we're 0 index, so that's why we've got the +1. So this is how we get that number that we want to display in front of each of the Pokemon. And as I'm adding the voiceover to the code, I'm realizing it would have been better to use the .id property instead of .name. Now, all of our Pokemon have unique names, so this really isn't a problem for us. But if you search on identifiable, you'll always be guaranteed to have unique values if you use ID. So if you have an issue where you need uniqueness and you are identifiable, use .id. And now I can head back to our label in the list, and I can enter the call of the function in the string interp with return index of our argument label shows up here, pass in creature, and look at that, Swifter. Our indexes are showing in our list. Let's scroll, and we can see new indexes loading with each new page. What if we click load all? And we'll scroll up and we can see all of the indices are loaded and they're showing up properly. How about if we search? And you can explore even more if you want. For example, you can check out a list of Pikachus. We see there's a Pikachu Rockstar. Ooh, a Pikachu PhD. I didn't know about that guy. Maybe we can get him to teach Swift. And you can look at these other ones. And with that, Swifty, your Catchable app is done. You've truly caught them all. But I hope you feel you've caught big learning in the process, where we've gotten an intro to JSON, where we covered API calls, parsing data, page JSON, recursion, codable, loading images with phases, searching, and so much more. Now, there's a lot more you could do with this app. We've only loaded a fraction of creature detail, so feel free to have at that JSON and update your user interface to your PokeTrainer satisfaction. And if you do, post a photo of your work online with the hashtag BuiltWithProfG, and you might be selected for a free My Mac Builds app stickers. I send them anywhere in the world for free. There are surprisingly few posters each week, so your chances of winning are quite high. For the past few months, I've been prepping lessons 7 days a week, so your likes, comments, and shares help me out greatly. If you can, please take a moment to help out, but stay subscribed as well, because there's more goodness to come. Code on, you code monster.